Hello everyone, welcome to our lecture series on ordinary differential equation. We are continuing with the formulation of ordinary differential equation. In previous lectures, we have taken up some of the questions which were asked in civil services examination. And now I am going to start with some of the questions asked in Indian Forest Service examination. Here the question says that we have to form a differential equation whose primitive is y is equal to a sin x plus cos x plus b cos x minus sin by x. So here we are given the solution of this equation, and from this we have to find the differential equation. So the first process is that we will write the given equation. The given equation is a times sin of x plus cos x by x plus b cos x minus sin x by x. Here we are having two arbitrary constants. That means we have to differentiate it twice. So if we differentiate equation 1, with respect to x, we get y dash as a times differentiation of sin x is cos x, and we are going to differentiate cos x by x, keeping one constant, one function constant, and differentiating the other. So this becomes sin x by x plus, then differentiation of 1 by x is minus x square, 1 by x square. So we can write it as cos x into x square. For this part we will move. So cos x differentiation is minus sin x. So this becomes minus of sin differentiation is cos. So this becomes cos x by x. And this minus minus become plus. So this is kept as constant. We need to differentiate it further because we are having two arbitrary constants. So we differentiate equation 2 with respect to x. We call this equation as 2. So y double dash is equal to a times differentiation of cos is minus sin of x, and here we will keep this one constant, 1 by x. So this becomes differentiation. So again for this part it becomes sin x by x square. Similarly for this one, this is our plus sin x by x square. Alright, so for this part this become minus minus become plus. So this become 2 by x cube cos of x plus b times differentiation of sin is cos. So this becomes minus cos. So here minus cos x by x. If we take, what it will become? If we take, this becomes sin x by x. So minus minus, this become plus. So this is our cos x plus 1 by x square. And here finally we can write it as cos x by x square. We have kept 1 by x square as constant. So here minus 2 of x cube sin of x. So we have got this. Now all we have to do is we have to rearrange this. So y double dash is equal to, now I am going to take minus sign over here and I will write a times sin x minus, because I have taken minus outside, so this becomes cos x by x. Similarly we will take here, already I have taken minus outside, So I can write it here, cos of x, and here it is plus. Since I have taken minus, I can write it as sin x by x. So this is one part. Now we are done with this, and this. All we are left with this 3 and this 3. So we can see this is the same thing. So it becomes 2 times, and I am going to take x square as common. So I can write it now, a times how much? Sine of x, alright, plus cos of x by x. For these two parts, I am clubbing it here. So I am done with this one, and this one. Now I am left with this part. So what it is? B plus B. So here I can write it as cos of x minus sin of x, because I have already taken 2 by x square as outside. So we have found our y double dash in terms of y. So this becomes as y double dash is equal to minus of y, this whole is y, plus 2 by x square y. So we can write it as, if we take x square on this side, this becomes 2y minus x square by y. So if we can rearrange it, so this becomes how much? X square minus 2 by y, minus 2y. So this is our differential equation. So we can write it in the standard format, x square minus 2y is equal to 0. So this is our answer. This was asked for 5 marks, but here we can see there is an interplay of differentiation. If you can differentiate number of times the order of the equation is, then you are able to, here the order of equation is 2 and here arbitrary constant will 2. All we have to do is the rearrange and we have to get our differentiation right. Now I am going to take the next question. So this is the second question that we have to solve. The question reads that form the differential equation that represents all parabolas, each of which has latus rectum 4a and whose axes are parallel to x-axis. So this question was asked in Indian Forest Service 2005 for 5 marks only. So first of all, we will write the equation of parabola with vertex alpha beta whose latus rectum is 4a and axes are parallel to x-axis. So what is going to be the equation? First, our standard format is to write the equation. The equation will be y minus beta whole square to latus rectum 4a into x minus that vertex. So this is the first step. We have formulated the equation. Here alpha and beta are arbitrary constant. Alpha and beta are arbitrary constants. So we have to differentiate it twice to get the differential equation. So if we differentiate equation 1 with respect to x, we get 2 times y minus beta y dash is equal to 4a. So here we get y minus beta y dash is equal to 2a. Alright, now we can call this as equation 2. Again we need to differentiate it because there are two arbitrary constants. So differentiate equation 2 with respect to x, we get y minus beta, this is y double dash, plus y dash into y dash is y dash whole square is equal to 0. So this is our differential equation, but we have not eliminated beta, so we will eliminate beta from equation 2. So we can write the value of y minus beta as 2a divided by y dash from here into y double dash plus y dash whole square is equal to 0. So we can simplify it further, we can write it as 2a y double dash plus y triple y dash whole cube. So we can write the result in standard format, that is 2a d square y by dx square plus dy by dx whole cube is equal to 0. So this is our answer. So now we are going to take the next question and the last question for this session. Now this is the question number 3 for this session, that it says prove that the differential equation of all parabolas lying in a plane is d square by dx square into d square y by dx square to the power minus 2 by 3 is equal to 0. This question was asked in IAS 1989, and this question is very important and it is lengthy as well. There are a lot of ways to do this question. Alright, so first of all we must write the equation of parabola and then eliminate the arbitrary constant and proceed. So equation of parabola lying in plane, that is a general equation, that is ax plus dy whole square plus 2gx plus 2fy plus c is equal to 0. This is our equation, this is the general equation that we are writing. Now we will differentiate it. Differentiate equation 1 with respect to x. So this becomes 2 times of ax plus by into a plus by dash, alright, plus 2 times of g, because we are differentiating with respect to x, plus 2 times of fy dash, and c is 0. So this is the equation that we have got. From this we can see here 2 is common here, here and here, so we can eliminate it. Alright, and from here I will assemble y dash. So y dash is abx plus by square, sorry, d square y plus, here also we are having the coefficient f. Now we will write the remaining terms. What are the remaining terms? This is a square x, alright, a square x plus aby plus g is equal to 0. So we are getting our y dash. So we can write the whole as a square x plus aby plus g divided by abx plus b square y plus f. We will write this equation as 2, and this is a very important point of juncture at this juncture because we will be using it many times. Now we will differentiate it one more time. So y double dash, and I take the minus sign on this side. So the differentiation will be abx plus b square y plus f whole square. I am differentiating with respect to x. So I am going to take it as abx plus b square y plus f. Alright, now I will differentiate this one. So this becomes as a square plus ab y dash minus of a square x plus aby plus g into, what is the derivative? Its derivative is ab plus b square y dash. Alright, so this seems to be a lengthy equation, but here a plus b dash and a plus b dash is common, so we can take that outside. So I am going to take a plus by dash is common, so only thing that remains over here is a, so I am going to multiply the whole with a. So this becomes a square b x plus ab square y plus af. Here a plus by is the dash is there, so b is common, so I will take multiply the whole by b. So this becomes a square b x minus a b square y minus gb, and this is our abx plus b square y plus f whole square. So can we cancel out some of the terms? Yes, we can. We can cancel this and cancel this one. We can cancel this and cancel this one. So we are left with a plus by dash into af minus bg divided by ab x plus b square y plus f whole square. So now I will put here the value of a plus by dash using this one. So I will need to compute this part. So for doing that, I will erase it, this portion, and I will write here a plus by dash, that is a minus, because minus sign is there, and in place of this we can write it as a square x plus ab y plus g divided by abx plus b square y plus f. Alright, so we will take this as LCM, ab x plus b square y plus f. Now I will take this one to this one here, so this becomes a square b x plus ab square y plus af minus of a square b x minus of ab square y minus of gb. So this one and this one will be cancelled, this one and this one will be cancelled. So what we get, we have got certain things in simplified format here, b square y plus f. So if I put this value over here, I will get my minus of y double dash. So I will write it over here, minus of y double dash is how much? Its value is af minus bg into ab x plus b square y plus f. This is whole square and this is one term, so this become cube, and here also we are having one, so this is the square. Alright, so we have got our minus of y double dash over here. So I will erase these portions over here and try to make some more simplifications. Now if I take this minus sign here outside on the right hand side, and if I multiply with minus 2, I will raise the power minus 2, so this becomes minus of 2. This is af minus bg to the power, how much? We can write it as minus of 2. This is already a 2, so if we will write in this one format, we can write it as whole a bx plus b square y plus f whole cube. So this becomes how much? Minus of 4, and this becomes minus of 6. Okay, so here we will take 1/3 of it. So this becomes how much? AF minus BG divided by minus 4/3 divided by ABX plus B square y plus F as minus of 2. So we can write it as ABX plus B square y plus F to the power 2 divided by AF minus BG into 4/3. So we have arrived till here. Now I will differentiate this one once more with dx. Okay, and I will be using this important point, that is a plus by dash is equal to af minus gv divided by abx plus b square y plus f. Alright, so now I am going to erase all of these portions. So this is the value. If I will take the differentiation for this part, minus of 2 with 3, so what I get is af minus bg to the power 4/3. If I differentiate it with respect to x, this becomes 2 times abx plus b square y plus f into ab plus b square y dash. So I can see b is common here, so I will take that b outside. This is abx plus b square y plus f divided by, again this becomes a plus by dash divided by af minus bg to the whole power 4/3. Now I am going to use it from here, as I told you earlier that I am going to use it once more. So when I am using it, what I will get? I will get this as 2b abx plus b square y plus f divided by af minus bg to the power 4/3. What is the value of a plus b y dash? That is bg divided by abx plus b square y plus f. So this one get cancelled. What we get? 2b, and this is our af minus bg. Here 4/3 minus 1 is 1/3. So we got dx by y dash minus of 2 3. So this is, but still it is not complete. We have to again differentiate. Since this is a constant, so we get our answer as, if we differentiate this. So this we have proved this equation. Invariably this is a lengthy question. We could have done it other ways also. That way is that you could have written this ax plus by whole square plus 2gx plus 2fy plus c, and you could have used the quadratic equation to write in terms of this one. Alright, sending all of this on this side and find the y and then differentiate it and again. That would also be a cumbersome. Alright, so this question was a bit tricky in terms of calculation and all, but this question might appear in this examination. So what we learned in all this session, that there were equation formulation on circle, parabola that we have just now done and some manipulations in forms of some functions. So thank you for watching this video. Please like, share and subscribe.